Hi students, MCQ number 6. The length of the two rods made up of the same metal and having the same area of cross section. This is the clue. They are 0.6 meter and 0.8 meter respectively. The temperatures at the ends of the first rod are 90 degree and 60 degree Celsius, and that for the other rod are 150 degree and 110 degree Celsius. So for which rod the rate of conduction will be greater? So we have to find out the rate of conduction for both the rods, which is greater than the other we have to find out. Now what is the clue given here is the length of the two rods made up of the same material. So since the same material, the thermal conductivity of the first rod is equal to the thermal conductivity of the second rod. So we can use the symbol K itself for both. They have the same area of cross section. Therefore, area of cross section for the first rod is equal to that of the second rod. So we use the symbol A for both. And the length of the first rod is given as 0.6 meter. So L1 is equal to 0.6 meter. And the length of the second rod is equal to 0.8 meter. Now the temperature difference delta T for the first rod, delta T for the first rod is 90 minus 60. Okay, so this is 90 minus 60. So this is equal to 30 degrees Celsius. And the difference in temperature between the ends of the second rod is 150 minus 110. So this is 150 minus 110. So this is equal to 40 degrees Celsius. Now the rate of flow of heat through the first rod is delta Q by delta T for the first rod. So this is equal to K into A, because they have the same thermal conductivity. Since material is the same, they also have the same area of cross section. So symbol is the same, into delta T1. So this is a delta T for the first rod divided by L1, and this is now equal to K. So K into A into delta T for the first rod is 30. So substituting 30 divided by length of the first rod is L1 equal to 0.6. Okay, now this is equal to, so K into A. So this is K into A into 30 by 0.6 can be written as 300 by 6. So 300 by 6. So this is 15. So let it be as it is. Now we will get the expression for the rate of flow of heat through the second rod. So delta Q divided by delta T for the second rod is now equal to K into area of cross section A into delta T for the second rod, delta T2 divided by L2. So this is now equal to K into A into delta T for the second rod is 40. So this is multiplied by 40 divided by 0.8. Now this 40 by 0.8 can be written as 400 divided by 8. So delta Q divided by delta small t for the second rod is equal to K into A into 400 divided by 8 is once again equal to 50. So you can see here the rate of flow for the first rod also is Ka into 50, and for the second rod also is Ka is equal to 50. Therefore the rate of flow of heat through the first rod must be equal to the rate of flow of heat through the second rod. So both the rods, it is the same. So same for both. Therefore option C is the correct answer. So once again, this problem also is based on thermal conductivity. In the previous problem, with the different conditions we solved, and here the conditions are different for the same material and same area of cross section. I hope you must have understood well. Fine.